Welcome to Exin's Cloud Computing Foundation courseware, which is brought to you by Pulley. And my name is Sachin Chinskar. I'll be with you throughout this course. The slides contained are basic presentation material to prepare students for the Exin Cloud Foundation examination. These slides may be used in a foundation training and as a basis for an accredited training. We know a good training will always require extra examples, elaborating subjects of special interest to the audience, and a good time schedule, including breakout sessions. The order in which the foundation subjects are presented follow the order of the exam requirements as prescribed by Exin, which is not necessarily the order in a good training course. So let's begin then. In the next slide, we will discuss the agenda of this course. We will start off by going through the principles of cloud computing, where we will be looking at the principles of cloud computing, which are concepts, definitions, characteristics, deployment, and service models. We will also understand the evolution of the cloud, which is virtualization, cloud architecture, and benefits of the cloud. This will be followed by implementing and managing cloud computing. Here, we will study to build a local cloud environment, the principles of managing the cloud, and the governance. After that, we will look at using the cloud and various ways of accessing the cloud and see how cloud supports business processes, service providers using the cloud, etc. Then we will go through security and compliance. This is a main topic which concerns everyone, and here we should be looking into security measures and risks along with legal and regulatory aspects. We will also deal with identity management on the cloud. Lastly, we will learn about the evolution of the cloud computing. Here, we will look at a business case. In the next slide, we will look at overview of cloud computing. Cloud computing is about providing IT-related services through the internet. Cloud computing allows flexible IT solutions to support the business based on clear service arrangements. The Exin Cloud Computing Foundation certificate requires an overview of the field and its relationship with other areas of information management. Such an overview is based on knowledge of the fundamental concepts of cloud computing, an understanding of the architecture, design, deployment of cloud computing, and its incorporation in the organization. In the next slide, we will look at 5 principles of cloud computing. Cloud computing is more than a service sitting in some remote data center. It's a set of approaches that can help organizations quickly, effectively add and subtract resources in almost real time. Unlike other approaches, the cloud is as much about the business model as it is about technology. Companies clearly understand that technology is at the heart of how they operate their business. Business executives have long been frustrated with the complexities of getting their computing needs met quickly and cost effectively. In a sense, cloud computing has started to become mainstream because these business executives have forced the issues into the forefront. The principles of cloud computing are the concept of cloud computing, the evolution towards cloud computing, the history of cloud computing architectures, and benefits and limitations of cloud computing. These are those 5 principles and focus areas that we'll be discussing in this module. In this figure, we see cloud computing, which offers a service that can be accessed through the internet. The service itself is both shared and scalable, and the most important factor is that all this is based on virtualization. In the next slide, we will look at the definition of cloud. The Encyclopedia of Britannica defines cloud computing as the method of running application software and storing related data in central computer systems and providing customers or other users access to them through the internet. Also, the definition of the American National Institute of Standards and Technology states that cloud computing is a model for enabling convenient, on-demand network access to a shared pool of configuration computing resources. For example, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. This is how various institutes define cloud. In the next slide, we will look at 5 characteristics of the cloud. One of the characteristics of cloud is on-demand self-service, where customers can easily get cloud services without going through a lengthy process. The customer simply requests an amount of computing, storage, software, process, or other resources from the service provider. Then we have resource pooling, which is multi-tenancy. The service provider can't anticipate how customers will use the service. One customer might use the service 3 times a year during peak selling seasons, whereas another might use it as a primary deployment or development platform for all of its applications. Then we have rapid elasticity, which is flexibility and scalability. Therefore, the service needs to be available all the time, that is, 7 days a week and 24 hours a day. And it has to be designed to scale upward for high periods of demand and downward for lighter ones. Scalability also means that an application can scale when additional users are added and when the application requirements change. This ability to scale is achieved by providing elasticity. Now let's think about the rubber band and its properties. If you're holding together a dozen pens with a rubber band, you probably have to fold it in half. However, if you're trying to keep 1,000 pens together, you'll have to stretch the rubber band. Why can a single rubber band accomplish both tasks? Simply, it is elastic and so is the cloud. Then we have measured services, that is, pay per use. Yes, there is no free lunch. A cloud environment needs a built-in service that bills customers. And of course, to calculate that bill, usage has to be metered or tracked. Even free cloud services such as Google's Gmail, internet-based applications are metered. Next, we have broad network access, that is, anytime, any place, any device. Just contrast this on demand response with the process at a typical data center. When a department is about to implement a new application, it has to submit a request to the data center for additional computing hardware, software services, or process resources. The data center gets similar requests from departments across the company and must sort through all requests and evaluate the availability of existing resources versus the need to purchase new hardware. After new hardware is purchased, the data center staff has to configure the data center for the new application. These internal procurement processes can take a long time depending on company policies. In the next slide, we will look at how IT becomes a utility. Mr. Vivek Kundra, the Federal Chief Information Officer of the United States of Government, states that there was a time when every household, town, farm, or village had its own water well. Today, shared public utilities give us access to clean water by simply turning on the tap. Cloud computing works in a similar fashion. Just like water from the tap in your kitchen, cloud computing services can be turned on or off quickly as needed. Like at the water company, there is a team of dedicated professionals making sure that the service provided is safe, secure, and available on a 24/7 basis. When the tap isn't on, not only are you saving water, but you aren't paying for resources you don't currently need. Utility is the functionality offered by a product or service to meet a particular need. Utility can be summarized as what the service does and can be used to determine whether the service is able to meet its required outcomes or is fit for purpose. Utility refers to those aspects of a service that contribute to tasks associated with achieving outcomes. For example, a service that enables a business unit to process orders should allow salespeople to access customer details, stock availability, shipping information, etc. Any aspect of the service that improves the ability of salespeople to improve the performance of the task of processing sales orders would be considered utility. Utility can therefore represent any attributed of a service that removes or reduces the effect of constraints on the performance of task. This is how IT becomes utility, where the dependency grows exponentially. In the next slide, we will look at some examples of cloud. Everyone has used a cloud knowingly or unknowingly. If you've ever used Gmail, Yahoo, or Hotmail, then you have been using part of the cloud since you started using these services. Let us look at some examples of cloud that we encountered on daily basis. For example, we use Facebook, Twitter, or any such social networking sites. Wiki, that is Wikipedia, online games, where the games are hosted on a server, played on LAN, Hotmail, which is one of the webmails, and Dropbox are the classic examples of some cloud services that we use on daily basis. Then for businesses, we have the CRM, the backup services, the enterprise resource portal, and financial information, which are an example of the cloud. In the next slide, we will look at the 4 deployment models, such as public cloud, private cloud, community, and hybrid clouds. Let us now look at various deployment models in cloud. There are 4 models. The first is a public cloud. As organizations move to eliminate private cloud components in favor of externally provided public cloud environments, the data center continues to empty and IT expands as a business component with a smaller dedicated server support staff required for daily operations, capital expenses for IT focus on client access technologies, while applications, services, and infrastructural elements become operational expense alone. Public clouds operate like public power production systems, bringing industrial scale cost efficiencies and hosting location flexibility to the organization. Following the utility model, transformation from building power generation to the distribution power grid available today. Beyond simple cost reduction, public clouds leverage efficiencies of scale and mobility of hosting to facilitate green initiatives aimed at reducing the carbon footprint or power consumption for the same class of organizational information technology services previously managed in isolated local data centers. Then we have private clouds. Through the implementation of a local private cloud, resident upon hardware located in local data centers, but running cloud infrastructural software. Organizations can take advantage of the self-service resource allocation and consumption metering for cost recovery billing models. The cloud software provides a standard platform for application development and availability even when the hardware remains heterogeneous, and in make and model transforming IT toward a utility business model, which is able to allocate resources based on service performance rather than on projections of planned resource needs. Then we have a hybrid cloud. An organization continue the transition made possible by enhanced virtualization. They can bridge local private clouds with other cloud offerings to create hybrid clouds, extending their resource pool beyond the systems present in local data centers. This allows an organization's services to develop greater capacity for response to peak loads and unanticipated demands. Billing continues to develop along the utility model, allowing load to determine cost as operational expense and internal billing for cost recovery. Then we have a community cloud. An offshoot of a private cloud is a community cloud. However, here a number of organizations come together, bring their monetary and IT resources together, and create a cloud that is accessible only to their organization. Now in the next slide, we will look at the private cloud or differentiate between the private cloud and data center. Private cloud is the first true transformation from traditional data center resource to cloud-based alternatives, enhancing the flexibility of resource assignment while still relying on local server resources. Because cloud computing is often discussed in terms of utilities, for example, providing resource based on utility and consumption as the power grid does. This stage of cloud technology aligns with the early 1900s when individual organizations had their own local power plants to provide electrical power. Mild efficiencies of scale can be achieved at this stage, but costs remain both capital and operational because tech refresh comes only from the organization itself. A private cloud resides on a private network that runs on a data center that is exclusively used by one organization, and it is owned, managed, and run by either the organization itself, a third party, or a combination of the two. It supports the organization's business objectives in an economic sound way, which is also a high security, which is compliant with legislation and regulations. In the next slide, we will look at a public cloud. As organizations move to eliminate private cloud components in favor of externally provided public cloud environments, the data center continues to empty and IT expands as a business component with a smaller dedicated server support staff required for daily operations. Capital expenses for IT focus on client access technologies, while applications, services, and infrastructural elements become operational expense alone. Public clouds operate like public power production systems, bringing industrial scale, cost efficiencies, and hosting location flexibility to the organization. Following the utility model, transformation from building power generation to the distribution power grid available today. Beyond simple cost reduction, public clouds leverage efficiencies of scale and mobility of hosting to facilitate green initiatives aimed at reducing the carbon footprint or power consumption for the same class of organizational information technology services previously managed in isolated local data centers. A public cloud is delivery of offsite services over the internet, which is sharing of resources, multi-tenancy, which means a lower level of security and privacy, which is aimed at a wide audience, which is compelling services like email and social media. It enables social networking and collaboration also. In the next slide, we will look at the community cloud. A community cloud, as defined earlier, is an offshoot of a private cloud. However, here a number of organizations come together, collect their monetary and IT resources, and collaborate them and create a cloud that is accessible only to their organizations. A community cloud is a type of a shared private cloud. It delivers services to a specific group of organizations and/or individuals that share a common goal. It is easy sharing of data, platforms, and applications. It is sharing of capital, expenditure, or otherwise expense facilities. It can be accessed 24 by 7 and support is available 24 by 7. It is a best example of a shared services and support contracts. Some examples would be regional or national education or research institutes, community centers, etc. In the next slide, we will look at the hybrid cloud. As organizations continue the transition made possible by enhanced virtualization, they can bridge local private clouds with other cloud offerings to create hybrid clouds, extending their resource pool beyond the systems present in local data centers. This allows an organization's services to develop greater capacity for response to peak loads and unanticipated demands. Billing continues to develop along the utility model, allowing load to determine cost as operational expense and internal billing for cost recovery. Hybrid clouds allow organizations to retain total control over data resources that are critical, sensitive, or transformative to their business operations while transferring less sensitive operations to more efficient public cloud service providers that can reduce cost through massive economies of scale, which is not possible in a local data center. Capital expenses are reduced because only key services might be retained on the organization's local server resources. This is also the model for mid-transition between local and public cloud services, allowing developers to test applications using local resources with very low tenancy and locally controlled high-capacity networking. A hybrid cloud is a mix of some of the models, combining several private and public cloud solutions from several providers into one IT infrastructure. Choosing specific services for either private or public cloud suitability is balancing between security, privacy, compliance versus price. In the next slide, we will look at types of cloud services. There are three types of cloud services. Software as a service. The key benefits are that the customer does not need to worry about the development and management of applications. Then we have platform as a service, where not owning a computer platform but being able to use it on demand can save costs in ownership, management, and maintenance. Then we have infrastructure as a service, rental of physical or virtual hardware like storage, servers, or internet connectivity is infrastructure as a service. In the upcoming slides, we will discuss these three types of services. Software as a service is often the first example of cloud computing that many users will experience, sometimes without even realizing they are interacting with the cloud at all. Hosted server applications available through a web browser or a thin client are often indistinguishable to the user who just wants to run the software application and not worry about application details operating behind the curtain. The key characteristics of software as a service are: it's a software hosted offsite, software on demand, it's a software package where no modification of the software is done by the user. It can also be a plug-in software, which is external software used with an internal application. Like we have our browsers with n number of plugins into it. Some examples are CRM, ERP, billing, and invoicing. In the next slide, we will look at platform as a service. Platform as a service expands an organization's capability to customize application development in the cloud by providing access to cloud program, development tools, and development environments. The key characteristics of platform as a service are: it is mostly used for remote application development and remote application support. The platform on which the cloud is being built may have special features, which comes along with a low development cost. There are a number of variants available for platform as a service, where we have an environment for software development, and a hosting environment for applications, and for storage. In the next slide, we will look at infrastructure as a service. The third category of cloud services, which is infrastructure as a service, allows a client almost complete control over applications, languages, and fundamental resources, supporting organizational services such as databases, storage, and networking. The background of infrastructure as a service can be found in the merger between IT and telecom infrastructure and services in the past decade. Some key characteristics are: it has dynamic scaling, a desktop virtualization, and these are policy-based services. Some examples of infrastructure as a service are hosting services supporting e-commerce, web hosting services that include broadband connection and storage. This brings us to the end of Unit 1. The Unit 2 is evolution towards cloud computing.